column is the second most vital structural element after foundation in the structure system. It is a compression member that transfers the gravity load from the superstructure down to the foundation. However, a column can fail in two ways. One, it can fail due to compression, and it can also fail due to buckling. Compression failure usually occurs to short columns. A short column is also called a stocky column. A column will fail by compression due to the difference between the allowable stress of the column and the axial stress on the column. Allowable stress is the calculated stress that the column can permit with its cross-sectional area, and the result obtained from the estimated load coming on the column from the superstructure divided by the cross-sectional area of the column is called the allowable stress, or otherwise you can call it calculated stress. From the relation, it is seen that the stress is inversely proportional to the cross-sectional area. That is, the smaller the cross-section, the higher the value of the allowable stress. On the other hand, axial stress is the actual stress that is induced in the column due to the axial load from the superstructure. You can see the difference. One is the calculated stress and the other is the actual stress. Due to unforeseen issues after the construction of the column, the external load may increase, which will result in increase of the axial stress. Now, if the axial stress is now greater than the allowable stress of the column will begin to crush. The column will crush even without producing any lateral deformation like bending or something, which will be a warning that, oh, I want to crush, are you prepared? But no, it won't do that. It will just bulge out and crush like that. At worst case, a compression failure may lead to the total collapse of the column, and you should know that the total collapse of just one column will directly or indirectly make the whole structure system to fail. This is how dangerous a compression failure of a column is. Another name for compression failure is crushing. Now, how can you avoid a compression failure in your column? To prevent a compression failure, we have to use a reasonable lesser cross-section for the column. By doing that, you will be having a higher value of allowable stress. Buckling. Buckling usually occurs to long columns. A long column is also called a slender column. The higher the slenderness of a column, the lower its load carrying capacity will be, and such column can buckle even under a small reasonable loading because they are unstable. In a simple term, buckling is the lateral or horizontal displacement of a column. Due to the slenderness of the column will bend sideways even under a smaller loading compared to that applied to the short column. Throughout the height of the column, there is a point at which the column will become unstable. That point is called bifurcation point. The buckling of a column will also begin from the same point. The maximum value of load that the column can withstand before buckling is called the critical load, and a small increment in this load will result to buckling. Another name for buckling is elastic instability. How can you prevent buckling? To prevent buckling, a column with a low slenderness should be used. That is, a column which height is not too much and its cross-section is not too small. That way you can prevent buckling, because the higher the slenderness of the column, the more it is liable to buckle. What are the differences between compression failure and buckling? For compression failure occurs in short columns, while buckling occurs in slender column. For compression failure, a column will need to receive a high stress before it can crush, while a column does not necessarily need a very high stress before it can buckle. Compression failure has to do with the crushing of the column, while buckling has to do with lateral bending of the column. Compression failure is as a result of high cross-sectional area, while buckling is as a result of small cross-sectional area and long height. Compression failure is more critical and dangerous than buckling. Another name for compression is crushing. Another name for buckling is elastic instability.